Hello you guys, here's your lesson for section 11.3, sectors, area, and arc length. Missy McCarthy, Okemos High School math instructor. In this lesson you're going to learn how to find the area of sectors and find arc lengths. You're also going to learn how to find the area of segments, but that wasn't mentioned in the objective, but it definitely is one of them. Okay, so for our vocabulary terms, we have this diagram here that just shows you what a sector is, and it shows you what a segment is. A sector is just a region that's bound by two radii of the circle and their intercepted arc. So we have our sector here, which is like a pizza slice is a sector of a circle. And then a segment here is a region bounded by an arc and its chord. So this shaded region here is called a segment. We've got lots of S words in this section. We've got secant, sector, segment. So it's going to be kind of difficult to keep them all straight. But that is what a sector is, and that's what a segment is. Now, if we're going to find the area of a sector, it's just like finding the area of a portion of the circle. So let's just give you a simple idea here. Okay, if I gave you a circle and I drew a segment with a central angle of 90 degrees, or I'm sorry, now I'm interchanging the words, and I drew a sector with a central angle of 90 degrees, and I asked you to find the area of that portion of the circle. What you would probably do is find the area of the entire circle. And then after you find the area of the entire circle, you would probably just multiply it by 1/4, because 90 out of 360 is 1/4. So that's what we're going to do here for every single sector. All we're going to do is find the area of the circle. So for the area of a sector, it's going to be the area of the circle, which is pi r squared, but then we have to multiply it by the portion of the circle that it represents. So if it's m degrees, it's going to be m out of 360. So pi r squared times m over 360 will give you the area of a sector. So if we're looking at this one, it says find the area of the sector and give our answer in terms of pi and round it to the nearest hundred. So when I do this, the area of sector HGJ will be 131 over 360 times pi times the radius, which is 12 squared. So that gives us, we're going to have some simplifying to do, 131 times 144 pi over 360. We could at least cut these in half. Half of 144 is, half of that is 2, and then it's 72, and half of that is 180. We actually could have, let me do it by 4. Because I think 4 goes into both of those as well. I'm just trying to reduce this fraction so we can write our answer in terms of pi. So 144 divided by 4, if I can punch the buttons correctly, is 36. And then 360 divided by 4 is 90. So it might be divisible by 16. 144, definitely divisible by 12. Yep, by 16, and 360 should be divisible by 16. I'm crossing my fingers. And it is not. So we got to do 12. So I would do 131 times 12 over 360 divided by 12 is 30 pi. And so 131 times 12 ends up being 1572 pi over 30. So we didn't choose the biggest number because we can reduce that by 2. So if I divide that by 2, 786, there we go. So it's 786 pi over 15. So that's our answer in terms of pi. So if we multiply that by pi, I don't know where pi is on this calculator. There it is. And divide by 15. All right, we get our final answer that the area of that sector is about 164.6. It says round to the nearest hundredth, so 164.62. So it's approximately 164.62, and our units are in square meters because we're doing area. All right, a windshield wiper blade is 18 inches long. To the nearest square inch, what's the area covered by the blade as it rotates through an angle of 122 degrees? So essentially, we're just looking at a circle here, even though the windshield is like half of that. And then the wiper is moving, and we want to know how much it will wipe. Well, the angle that the wiper sweeps out is 122 degrees. So what's that area? Well, the area of the sector would be 122 over 360 times pi times the radius squared. And the radius is 18 inches because that's how long the windshield is. So we've got 18 squared times 122, and then that's over 360, and then that's times pi. So it looks like we have got approximately 344 does it tell us what to round to the nearest square inch? So that would be 345 square inches for this windshield wiper. Now, we're not taking into account, I know that most of you have seen windshield wipers that are shaped like this, and some of them only wipe like that part of the window. This part is like still dirty, but we're just assuming that it's going to wipe the whole thing. So it's wiping the entire sector, not just the entire sector, not just part of it. All right, so next we're going to take a look at how we would find the area of a segment. So if we want the area of the segment, what we could do is take the area of the sector, so the area of the segment would be the area of the sector, and subtract the area of the triangle. So it's kind of like when we did our composite figures. To find the area of this guy, it's a composition of these two, this one minus this one. So we're going to use that to find the area of the segment in the next problem. Oh, excuse me. So find the area of the segment LMN to the nearest hundredth. So we know that this angle is 120 degrees. And we can find the area of the entire sector. So the area of the segment is equal to the area of the sector minus the area of the triangle. So the area of the segment equals, the area of the sector would be 120 out of 360 times pi times the radius squared minus the area of the triangle. Let's draw that triangle here. It has a 120 degree angle. We know this is 9. If we drop this down, we know that, let's see, this is 60 degrees. We need to find the height of the triangle. So to find the height of that triangle, and we could also find the base of the triangle. Well, if that's 60 and this is 9, then that means across from the 30 degree angle, I'm just going to use what I know about 30, 60, 90 triangles, is half of the 9, so it's 4.5, and this is 4.5 square roots of 3. So could you use trig? Yes, you could use trig, but I'm just using what I know about 30, 60, 90 triangles. So the area of this triangle, that means this whole base of the triangle would be 9 square roots of 3. So the area of the triangle would be 1/2 the base, which is 9 square roots of 3, times the height, which is 4.5. Now it says find the area and round our answer to the nearest hundredth. So I'm just going to type this all in. This is essentially 1/3 or 81 thirds times pi minus, let's see, what would that be? 9 times 4.5 root 3 all over 2. So 81 pi divided by 3. That is approximately 84.823, and then 9 times 4.5 times the square root of 3, and then divided by 2 is 35.074. And if I subtract those two, 84.823 minus 35.074, I end up with an area of approximately 49.75, and we're in square centimeters. So again, it's just the area of the sector minus the area of the triangle to get the area of the segment. Okay, lastly, we're going to talk about arc length. Arc length is pretty much just the length of the arc along the circle with endpoints on the radii of the circle. Okay, so this is the endpoint of one, that's the endpoint of the other. These are radii, and then the arc length would be this green portion here. So we're going to find arc length, let me go back. We're going to find arc length in the same way that we found sector. If we know what portion of the circle this is, then we can use that to find the portion of the, not area, but arc length would be a portion of the circumference. So if we said that this was A degrees, let's say, then this is A degrees. So our arc length can be found by doing that portion of 360, so A out of 360, and your book may use a slightly different letter, but it's a portion of the circumference, which is 2 times pi times r. It's not a portion of the area. So it's just a portion of the circumference. So now we're going to find the arc length. We're going to give our answer in terms of pi and round it to the nearest hundredth. The arc length is going to be an arc created with a 62-degree angle in a circle with a radius 2 meters. So I'm just going to draw this out. We got a circle with a radius of 2 meters. The angle that's created is 62 degrees. The arc that we're interested in finding is this guy here. We want to know how long it is. And the radius is 2. So the arc length is going to be 62 out of 360 times 2 times pi times 2. So we can reduce things here. Half of 62 is 31, so we would have 31 out of 180 times 4 pi. I know 4 goes into 180. 180 divided by 4 is 45. So we have 31 pi over 45. So that's one way we can write our answer. But it is approximately, let's do 31 pi divided by 45, and we get an approximate answer of 2.1, round to the nearest hundredth, 2.16. And that would be meters long, because again, we're talking about the length of the arc. We're no longer talking about area. All right, make sure you rewatch any parts for area of a sector, area of a segment, and arc length. If you're watching, please be sure to type in questions, and I will see you in class. Enjoy the beautiful weather.